All right, we're going to look at ratios, and we're going to keep it pretty basic this time around, just an intro to ratios. The first thing is there's three different ways to write a ratio. And my question right here tells me to represent the ratio of squares to circles below all three ways. With ratios, you have to make sure that we're writing it in the exact same order that the statement tells me to. So this says ratio of squares to circles. So I need to make sure all of my ratios are in that same order. So if I look, I have 4 squares and I have 3 circles. So in words, I'm just going to write the word 2. So I have 4 squares to 3 circles. So my ratio would be 4 to 3. A colon, semicolon is very similar to that. We're just going to put 2 dots. So my ratio of squares to circles is 4 to 3, just like that. And a fraction is what we've been doing all year long. I'm just going to write 4 over 3 because my ratio is 4 to 3. There's also 3 types of ratios. What we just looked at was a part to part. We're comparing 2 different parts. We're not looking at any totals yet. So an example of that would be squares to circles, or they could have asked us circles to squares. Either one would be a part-to-part ratio because I'm comparing 2 different parts. The second one is a part to whole. So you start looking at a total. So I could have compared squares to the total shapes, which in that example, that would be 4 to 7, just one way to show it. I could have also compared circles to total shapes. And since I had 3 circles and 7 total shapes, my ratio of that would be 3 to 7. That's a part to whole ratio. A whole to part is the same thing as part to whole, it's just flipped. So I would be comparing my total shapes to, I could do squares, which would be 7 to 4. And I could also do total shapes to circles, which would be 7 to 3. So it matters the order that they say it. A whole to part ratio, you're comparing the total to just a part. We can also use ratios to solve problems. They're very similar to equivalent fractions, and that's a concept that we're going to be using a lot. Number 1 says, how many total shapes would there be if there were 9 circles? Well, we know that for every 3 circles, we have 7 total shapes. So I just wrote a part to whole ratio. And it's asking me if there were 9 circles, how many total shapes would there be? So if I had 9 circles instead of 3, how many total shapes would there be? Well, we know that to get from 3 to 9, all I have to do is multiply by 3. So I could do the exact same thing on the bottom. It's equivalent fractions or ratios. So 7 times 3 gives me 21. So if I had 9 circles, I would have 21 total shapes. We're going to do the same thing on, or very similar on the second one. It says, how many circles would there be if there were 36 circles? It should say squares. So I need to write a ratio that's circles to squares. Well, I know I have 3 circles for every 4 squares. And it's asking me if there were 36 squares, how many circles would there be? Well, we know to get from 4 to 36, I could multiply by 9. So I can do the exact same thing on the top. 3 times 9 would give me 27. So that would be 27 circles if there were 36 squares. All right, that's a basic intro to ratios. You should be able to write it all three ways, identify if it's a part to part, part to whole, or whole to part, and you should be able to use equivalent fractions to help you solve some problems with ratios.